Okay, the next method in this chapter is Heun's method. And in this method, we are actually improving the answer by improving the slope. Okay, we do a little bit twist on the slope in order for us to get a better estimation for the answer. So this method involves determination of two derivatives for the interval h at initial point and end point. Okay, then the two derivatives, they will be averaged to obtain an improved estimate of the slope for the entire interval h. So we have two formula here. The first one is the predictor and then the corrector. So for the predictor formula, we actually predict a new value of y. This is a temporary value of y, and we use this value in the corrector equation to calculate the slope that we're going to use for the final answer. So this is where the twist is. We're actually averaging the slopes between the previous data or the initial condition. If we are calculating the first data, we use the initial condition, and then we use this newly calculated or the initial calculated value of y, which what we calculated in this predictor equation, and then we average and we use the slope to calculate for the final answer. So the Heun's method, also known as predictor corrector approach, and this method involves iteration. And of course, as you know, when it involves iteration, it has to have a termination criteria. So we use EA here. So again, the EA must be less than ES. So if the EA is less than ES, we can terminate the criteria. Okay, so let's see how actually this method works by working through going to the example here. Solve the following problem using Heun's method with h equals to 0.5 from x equals to 0 to 1, in which the initial condition is given when x equals to 0, y equals to 1. So iterate the corrector to ES equals to 1%. So the iteration actually only involves the corrector. And this is our ODE. So let's see how we can solve this. We have initial value when x equals to 0, y equals to 1. Alright, so this is our data, x and y, 0 and 1. So we are asked to estimate the value, what is the value of y when x equals to 0.5 and when x equals to 1. First step, we need to calculate the slope first for this point. So for the slope for that point, fxi, yi, f0 and 1. So we just substitute this 0 and 1 into the ODE equation. dy dx equals to yx squared minus 1.1y. Okay. So here, 1 times 1. So this is negative 1.1. So we got the slope for this data, which is negative 1.1. Predictor, using the predictor equation, we just predict the new value of y. Okay, and yi plus 1 equals to 1 minus 1.1 times 0.5. So this is just a normal Euler equation, and you will get 0.45. Alright, for the, I would say as a temporary value of y, or the predict your first prediction or initial prediction of y. So when you calculate the slope for point 0.5 and 0.45, you just substitute all these two values into this equation, you will get so here we will get negative 0.3825. Now that you got this, the value for this slope, so now we use corrector equation. Yi plus 1. So this is the final estimation of y, okay? 1 plus, we average the slope. So the slope just now was negative 1.1 plus this divided by 2 times 0.5. So you will get 0.629375. But it doesn't end there. Okay, you need to calculate the EA. So the approximate error, current approximation minus the previous divided by current. So the current approximation just now was 0.69375. 0.62975. 0.62975 minus the previous one, which is this 0.45, the previous y, the predictor, the y, the initial prediction of y, which is 0.5, okay? Divided by 5 times 100%, so this is absolute value, and you get this 28.5%. So the EA is still more than the ES because the question states that your ES is 1%. According to this, you need to do more iteration. So this is not your final value of y. So you need to iterate again. You need to repeat the whole step again, just the corrector. Okay, so in order to calculate for the next iteration, we calculate new corrector value for the y. So slope for next point, to calculate for the next point, which is the one that you have just calculated just now, which is this one, 0.5, and this value, the corrector value. You only iterate the corrector. You don't need to iterate the predictor, okay, just corrector. So in order for us to calculate for the next point, so the slope for 0.5 and 0.62975 is yx squared minus 1.1y. This one is 0.62975 times 0.5 squared minus 1.1, and then this value again. Alright, this value again. So solving this, you will get negative 0.534968, and then calculate average slope, negative 1.1, negative 1.1 plus this, which is 0.534968 divided by 2, and solving this, you will get negative 0.817484. The solution for this question is very long because it involves iteration. You need to keep on iterating the corrector until your EA is less than ES, then only you can move on to the next point, which is the next x. And now we are still at x equals to 0.5, trying to find the best answer for the y, the corresponding y, when x equals to 0.5. When we got the average slope, so the second, I would call this as the second, alright? The second iteration, which is here 1 plus negative 0.817484 0.484. This one, this slope is from this just now, the average, okay, times the step size 0.5. So this is 0.591258. So this one is the initial condition. This is when the first data, which is x equals to 0 and y equals to 1. Okay, so now that we got a new value or a new answer for the corrector, we can calculate the EA and check whether it's more or less than the ES. So 0.591258 minus the previously calculated, which is this one, 0.629375. 0.629375 divided by this 0.591258 times 100%, and this equals to 6.45%. Still, it's more than ES. You need to do third iteration. Okay, let's go on. Let's move on to the third iteration. So next slope is when 0.5, and the newly calculated just now we use this value, okay, the second iteration value, which is 0.591258. So in order to calculate the slope, which is yx squared minus 1.1y, we just substitute all the values, all these two values inside this formula. So we will get, I just give you the answer lah, right? Negative 0.502569. Okay, so now you got the slope for this second iteration value. So we can calculate the average slope. So this one is negative 1.1 minus 0.502569 divided by 2. So this is negative 0.801247. So now we got the average slope. We can calculate the third iteration for this y, which is 1 plus, this is the initial condition, yeah? The initial condition, the first data when x equals to 0, y equals to 1, plus the slope of this, negative 0.801247 times 0.5, the step size. So now you got 0.599357, and you can calculate your EA. Your EA is this value, 0.599357 minus, minus which value? The second iterated value, which is this value. Okay? Minus 0.591258 divided by this value, 0.599357. So the value, so the answer for the EA, you will get 1.35%. Still, you need to do your fourth iteration because the EA is still more than the ES. So bear in mind, ES here is 1.0%. So this is more than 1.0. So you need to do your fourth iteration. Next slope is when f.5 with the third iteration data, which is 0.599357. So just substitute this into the slope equation. So you will get your answer as negative 0.509454. Okay, so now you calculate your average slope. So this, you will get negative 0.804727. So now you can calculate your fourth iteration. So 1, this is the initial condition. still use the 1 plus this, the average slope here, which is negative 0.804727 times 0.5, and you will get 0.597636. So you can calculate your EA. 0.597636 minus the previously calculated value of this, 0.599357, okay, divided by 7636. Okay, so your EA is finally you reach less than ES. So you can stop. You can stop iteration, and your final answer for Y is this. Okay, so you have your data just now, X and Y. X0, Y1, when X is 0.5, Y is 0.597636. And now it's time to calculate the value of Y when X equals to 1.0. Next, value when X equals to 1. Okay, so what is Y? Again, we need to use the predictor equation. We need to find out what is the initial value of Y. As you know that our data, I just need to keep on highlighting this to you, which is 0 and 1. This is 0.5, 0.597636. Okay, now 1.0 is the value of Y. So for the predictor equation, we're no longer using the initial condition, but we use the previously calculated data. So this is 0.597636 plus slope times 0.5. So this is just a simple Euler equation. So the slope at this point is, substitute all these values into the formula just now. So you will get negative 0.5079906. That will be the slope. So for the corrector equation, yi plus 1. Oh, sorry, this is still we are in the predictor, okay? So for the predictor equation, yi plus 1 equals to 0.597636 plus negative 0.5079906 times 0.5. This is from here. Okay, so this you will get 0.3436407. Now this is the initial value of the Y, and now we use the corrector to work out what is the next value of Y. So what you have to do is you need to calculate the slope first. So let me just write it here. Okay, next is the calculation of the slope at 1 and this one, 0.3436407. Okay, so this is the slope for this point. Just substitute these 2 points into that slope equation. So you get the answer as negative 0.03436407. And now we are looking for average slope, negative 5079906. So where does this come from? This comes from the slope at this point. Okay, at this point, this one plus this newly calculated slope here, this one. So minus 0.0343 6407 divided by 2. So you will get negative 0.271177. And now you can use this to find the correct value of y, correct the equation. So here is y I plus 1. Okay. So 0.597636. Those who are still wondering, where does this come from? This comes from here. Okay. Value of y here. So this plus negative 0.271177 times 0.5. So this is 0.462047. And it's time for you to calculate the EA. So check whether it is less or more than the ES. So this one is 0.462047 minus the previously calculated y, which is this one, divided by this 0.462047 times 100%. So this one you will get a 25.63%, still more than the ES. So of course you need to do your second iteration.
So why don't you try on your own to solve for all the other values of x, using the same method that I have explained before. So here are the answer. This one I have already, this one is the initial condition, and this is already been solved just now together. So this is 0.59763665, and the other one is when x equals to 1, y equals to 0.4590875, and then 1.5, 0.626127. So you can try this. You don't have to try until 2. Just as long as you get the answer for 1 and 1.5 is good enough. It shows that you understand how to do the calculation. So again, Heun method with iteration can be quite confusing. So please be careful in solving the answers for each x. All right, good luck. Thank you.